All right, let's get started. There we go. Well, we've come to it. This is our last lecture in this class. I can see you're having a hard time containing your excitement. That was a joke. In all seriousness, so this is our last content lecture for the semester. Just so everybody's clear on the schedule, what's going to happen is this. Today, we're going to have a lecture. It's actually going to be somewhat short because I want to give you all time in class today to work on your homework 8, your final homework. Next Tuesday, we will not have content in the lecture. We'll just, it'll be like the last time where it's just a homework day. So I do recommend that you come. I'm not going to make you come, but I do recommend that you're here. I'll be here, and just the fact just being here and working on your homework, if I'm here, if you've got any questions, it would be a good day to be here. The only other, so it'll be due next Thursday, and you should have plenty of time to do this homework between lecture today and Tuesday. Only other announcement I'll mention is the course evals. We actually got a heck of a response last time just in class. Two things. One, not everybody has completed it. See, the only thing I can see is the number of students that have completed it. And there's students that have still yet to do it. So that's point one. And point two, there's also an imbalance between the number of students that have completed it and the number of students that have told me they completed it. We have the rush of Engineering 111 students. Goodness. You all are just raring to go. As I was saying, not everybody's completed their course eval, and there's an imbalance. I believe I have only 16 names that have shown me evidence that they've completed it, but actually I think 17 or 18 students have actually done it. So there's a couple of you. What I would do is I would go on Blackboard. If you don't have a grade assigned for your course eval and you've done it, show me, sometime after class, and I'll have you on the list. Sound good? Again, free points, so that's always a good thing. Okay, before we get started in the lecture, I mentioned this a little bit before class began. I'll mention it now, especially for those of you that just walked in. You're going to want to log in and get MATLAB started. Also, if you're using a flash drive or a V drive, we're going to need to use that today. You'll definitely want to create a separate folder for today because we're going to be dumping data files in and out of a given folder. So with that, I'm going to go ahead and just get into the notes. I'll pass the homework assignment out. I've got hard copies after lecture. Okay, so today our final topic with MATLAB that we're going to cover this semester, and the professors, we debated it a little bit. We were going to cover user-defined functions, and that's a useful topic, but in the end, if you can do the programming that you've done so far in this class, user-defined functions are pretty simple. We wanted to give you all some more robust capabilities. So being able to manage data is really a good place to close out the semester on MATLAB. So I think the best way of describing or working with data management is looking at this. I want to go back to this script. This is a script we looked at last time, where the idea was, we've got this given matrix A, and we were squaring each term, okay? Now, so let's be clear. So I've got a matrix, and I could sit there and count how many terms it has. I believe it has something like 12, 13 terms, something like that. And this loop says that for each term, I'm going to square the value. Now, the thing about this is, in order for this to have worked, I had to actually type that matrix into the script, right? I had to actually go in and define each term. Well, that's fine for if you have a matrix that has 13 terms. I can sit there and just type it out. What if it has 13,000 terms? Am I going to just fill my script with one big matrix? Lines and lines and lines of just data? There's a better way of handling that, okay? So I want to show you how we can handle that. Okay, the first thing I want everybody to do is I want everybody to open MATLAB. I want you to just go to the command window. Make sure all your variables are cleared out of your workspace, if you have any there. And I want you to type in this matrix, and I'll type it in with you. So let me see. Let's see. Let me give me a second. Okay. Wanted to have my hard copy here. So A equals, and what do we have? We have 5, 17, minus 3, 8, minus 7, 12, 15, 20, negative 6, 6, 4, minus 2, 16. And press enter. Now, if you've done that correctly, you should have only one variable in the workspace, and yeah, it's got 13 terms. Okay? Now, let's say that this particular data, or this particular data set, is something I plan to manipulate in MATLAB quite a bit. Or, another way of looking at it, imagine that instead of 13 terms, it was 13,000 terms. I wouldn't want to have to type that out every time I run a given script. Or better yet, I'd like a way of referencing that data easily. Okay? So here's what I want you to do. Sorry about that. Here's what I want you to do. Okay, look here at the top under the current folder. See how mine says C, and then it says Users, it says Michelson, Documents, MATLAB. Everybody see that? Okay. What I want you to do is I want you to go up there and navigate to whatever folder that you all created. So if you're using a flash drive, if you're using a V drive, go up here and navigate to your particular folder. So you can do that by, sort of clicking one of these and sort of going in this, go from level to level. I'm going to go to the very, you can click this this little button right here, and it'll bring up I think a pretty familiar layout. The folder that I'm going to use is I'm going to go to my V drive. So I'll go to this PC, go down to V drive, and I'm just going to use this folder that says MATLAB because I created a folder specifically for this lecture, and the folder's empty. There's nothing in it. So we'll hit Select Folder, and if you notice, it should say V MATLAB. Okay? So you all navigate to whatever folder you think is, whatever folder that you've created. If you put something on your flash drive or your V drive or what have you. But the big thing is you really want to make sure that you're navigating to a folder that you can easily locate. Like I know where my MATLAB folder is in my V drive. So I'll give you all a second to, if you haven't already created a folder, to navigate accordingly. You might want to call the folder Lecture 28 or something, since that's what we're doing today. While you all are doing that, let me go to my actual directory, like actually go to the folder and pull that up. So going to the V drive, MATLAB, and then this is the folder I'm working with. Okay. Has everybody got that navigated? Has everybody navigated to that? Okay. Now what I'm going to do is this. I'm going to enter a very simple command. I'm going to go into the command window, and I'm going to type in save. Whoop. Maybe I could actually type. I'm going to type in save A. Okay. And press enter. Now, if you did that correctly, you should note, or you should see on the very left of the MATLAB interface where it says current folder, you should have a new file pop up. Does everybody see that? And if you open up your directory, open up your folder in File Explorer or Windows Explorer, you should see this right here. And it might say something over here on the right, like Microsoft Access Table Shortcut or something like that. That's fine if it says that. That's no big deal. But I want to make sure everybody has done that and is able to find that file. Okay, so you haven't changed your directory. This is important. So, okay, you've got yours. Because ultimately, this is what I want to see on everybody's screen. I want to see, your folder and that A file in that folder. So, yes. Okay, do you have a flash drive? What folder are you going to work off of?
Put it in the B drive.
Okay, so you're going to browse for folder and go find wherever it is. You good?
Yeah, I got it. I was just fixing on my phone.
You suggested put it on the
Yes. Yeah. Okay, what you can do is just do that. Now, don't put it on your site CS folder. Put it somewhere on your V drive or a flash drive or somewhere like that. Like your V drive is, yeah. Okay, just hit select folder. Now do it again. Do your command again. Yes.
When I got here, somebody had unplugged this computer and then put it in the port here, but didn't put, they just put it in the port there.
That's considerate.
Very.
That's considerate. All right, do you have yours? You have yours. You have yours. Do you have yours? Okay. All right. Did you change the folder? Whoa. Oh, have you run it?
Oh, no, I haven't.
That'll do it. Now run it.
Okay.
There you go.
Thank you.
All right. Everybody have theirs? You have theirs? You have yours? Do you have yours?
Yeah, it's right here.
If you can find it, I'm.
Yeah.
There you go. Everybody over here have theirs? Okay. Are you good? Okay. Everybody over here? Y'all good over here? Okay. All right. So, all right, everybody. All right, let's set up. So, what happened just now is all right. So, up until now, the only type of file that we've been working with is a script. Or all right, everybody. All right, settle down. Up until now, the only files we've been working with are scripts, or we call them .m files. And a script file is just a series of instructions, if you will. Okay, so let me go past here. All right, okay. We good? We good? We good? All right. Up until now, we've been working with just scripts, which are really just series of instructions. What we've just created just now is what's called a mat file, a .mat file. And a .mat file is literally, it's just data. Okay? It's just a table of numbers that's MATLAB friendly, if you will. So that file that we created just now, has been stored as external data, or that variable, I should say, that variable that we created has been stored as external data. Okay? So let me explain where that's useful. Okay? What I want everybody to do, I want everybody to close MATLAB. Close it. Okay? Now MATLAB's closed. Okay? It's closed. All right? Now, I know it's going to sound silly, but reopen it. We'll let that load up. Okay, so now I've got MATLAB loaded up. What I'm going to do is this, okay? Before, what we would have to do is if I wanted to use that A variable, I'd have to type it all out again, okay? That's not what I'm going to do. What I'm going to do instead is I'm going to go up to the file navigator, if you will, this file locator, hit that little drop-down arrow, and then go and find my V drive or find my folder. So there's my folder, and if you notice, you should have the A matrix in that folder, okay? And what I'm going to do is before I saved that data, now I'm going to load it. So load A. And if you notice, now that A variable is within your workspace. Does everybody see that? So now I can start manipulating that variable. I can start taking averages and plots and standard deviations, etc. And I didn't have to go through and redefine it over and over and over again. So what I want you all to have the ability to do is create, variables or tables of data, etc., save them as mat files, and then be able to call them later. Does that make sense? That's something I really want you all to have the ability to do. It's not that big of a deal for this matrix because there's only 13 terms. What if there were 42,000 terms? Now, 42,000 terms, that might seem a little crazy. You've already dealt with that, though, in this class. Remember our in-class exercise where we were messing with the gross vehicle weight data? I seem to remember there was about 42,000 terms in it, right? You wouldn't want to have to type that data out, right? You want a means for MATLAB to be able to interpret that data, okay? Does that make sense? All right. So I want to show you something real quick. So remember this program right here? This was the program that squared each term. Well, what I want to show you is here is another version of that program. And if you notice, that program is literally the exact same except for line 4. Instead of typing out that matrix, I've typed out the term load A. Okay? This actually is a much more robust program because look at what this program will do. I know this program is fairly long, but ultimately, what is the purpose of this program? What's it trying to do? Well, it's trying to take each term of A and square it, right? But now A could be anything. If I changed A, if I used a different file for A, it would still work, right? Assuming it was a vector, right? Does that make sense? Now, here, this yellow note right here is really, really important, okay? When we ran that load command just now, we had to navigate to the same folder, right? An easy way of ensuring everything's going to work is that in order for this load command to function properly, your A file has to be in the same folder as your script, okay? Because it's going to, when it runs the load command, what MATLAB's going to do is it's going to search that folder for A. If it doesn't find A, it's not going to be very happy, okay? So that matrix has to be within that same directory. Does that make sense? Everybody okay with that? Okay. Now, I do want to talk a little bit about some additional saving and loading aspects in MATLAB. I can send you all this script if you want, but there's really not a whole lot to it. Let me show you something real quick. I'm going to go to this MATLAB file. Let me go to my lecture notes. Let's pull this one, I think it is. And I'm going to copy and paste this script inside my folder that I've been messing with. Now let me open the script to show you what it's doing. This script is literally what you see here on this slide. Let's take a look at what's going on. So let's take it one line at a time and make sure everybody's clear on what's happening with the script. So the first 2 lines, what is it doing? It's clearing out the command window and it's clearing out all the previously defined variables, right? Okay. So what's it doing for x and y? Well, x, it's a vector from -5 to 5 spaced out in increments of 0.01. So it's starting to look, so that's a lot of points, right? And then what's y doing? It's squaring each of those points. That's where that element by element, that dot operator comes into play, right? Starting to look like what this is one big plot, right? That's what we're trying to do. I mean, we never really messed with evenly spaced vectors with so many points in it unless we were trying to do a plot. Okay? Now what I want you to pay attention to, and this is really important, is what's going on line 7. Okay? Before, if we wanted to plot it, we would just say plot xy, right? So let me show you. Let's mess with that a little bit. Okay, so okay, here's the code, and let's make it a little more familiar. First off, let's get rid of all of this. And let's just make it look like that. That should be fairly familiar, right? Everybody should be able to recreate this quite easily. And if I run the plot, I should get a figure that looks something like this, right? It's a parabola. Everybody okay with this? That's simple, okay? Well, one thing I'm going to do is I'm going to make this plot a little fancier, and here's what I'm going to do. I want to go to line 7, okay? And I'm going to, instead of just plotting it, I'm actually going to assign that plot to a variable. I'll call it something like FIG for figure, okay? So when you run the program, and I look at the workspace, I should have an X variable, a Y variable, and then a figure. Everybody see that? Everybody okay with that? Now, watch this. I'm now going to go down a little bit on my editor, and I'm going to type in save as. And what am I saving? Well, I'm saving the figure as some file name. Okay, now what's my file name going to be? Well, this is a parabola, right? So maybe I'll save it as parabola, and then what's an image file in Windows? What, JPEG, right? Okay, so what it's going to do is it's going to take that plot and it's going to save it as a file in my folder. Now, if I run that program, and go to my folder, look what I've got. I've got a little image, a little parabola. I could take that, I could put it in a Word document. Now, I promise it's there. There we go. So now I've got a photo file. I could take that photo, I could put it in a Word document, I could post it to Instagram, you know. Joke, that one was a little funnier than the previous joke, right? Yes?
Whenever I run the script, I have indicators along the
That,
x-axis, and then when I save it, I don't.
I was getting ready to say, I was getting ready to say that. One of the limitations or the things you've got to watch out for is the figure window in MATLAB and then the JPEG conversion sometimes doesn't match. For instance, your grid spacing might be a little different. There are ways where you can actually force MATLAB to adhere to a particular grid spacing. I sort of left that out of discussion because I wanted everybody to understand the basics. But there are commands where you can say, no, I want grid spacing every one increment, and it will force your image to do that accordingly. It's just a little bit more code and a little bit more syntax. Make sense? All right, is everybody okay with this? So you all are going to post this to your Instagram accounts, right? That's a joke, not a very fun one. Okay. All right. The big thing that I want everybody to keep in mind is this line right here. Instead of just plot, assign that to a variable if you want to export it as a JPEG. Everybody okay with that? Okay. Now, let's talk about data management. In other words, if I have a data file, some massive quantity of numbers, how do I convert this to a MATLAB-friendly form? Okay. Well, let's see. So I've got here some strain gauge data. Y'all remember seeing this strain gauge data? We looked at this a while back. This was that field test I did out in Iowa near the horse and buggies, right? You remember that? Okay, well, I have here a text file with a bunch of data, and ultimately I'd like to be able to convert this into a MATLAB-friendly form, okay? Fortunately, the importing capabilities are a lot like Excel, so it makes things a little nice. There's an import data wizard in the very top of the MATLAB interface. It's if you go to Home, you can see it right here. We're going to import this data. Okay. Now, if you look on your Blackboard interface, you should see a text file on your lectures. Everybody see that? Okay. Here we gotta be careful on a couple things though in order to do this properly. So I'm going to load up Blackboard, and once this decides to load up. let's see. Well. Okay, so I'm going to go to Engineering 111. I'm going to go to Course Content. And I'm going to turn Edit Mode off so it looks like your interface. Now, if you're running this, I'm running this in Chrome, and if you just open the text file, it just probably does something like that, right? Everybody see that? Okay. What I think you need to do is, if you're running it in Chrome, you need to right-click and you need to click Save Link As. Okay. So save that link. You should have a little thing that pops up, and then put it in your folder, whichever one you created, and just save that to your folder. And you should have a text file that we can actually manipulate. That's one of the disadvantages of using Blackboard, is that if you post a text file, it's just going to open it. So we actually need to save the file to our hard drive. All right. Has everybody done that? So if you look on your directory, you should have, it should say Engineering 111, Lecture 28, and you should have a bunch of data like this. Everybody okay with this so far? Has anybody, you want me to wait a little bit, or? Okay. All right. Now, what I've done is I've put that file in that directory that I'm after. What I'm going to do is this. Let me close this. Let me clear out all my variables. So, oh, what is going on? Okay. All right. So I've cleared out all my variables. I'm going to import some data. Okay. Now to do that, I'm going to click the Import Data button over here on the top under the Home tab. So click Import Data. And you should already be navigated to your folder, and you'll see it's right here. It should say Engineering 111 Strain Gauge Data. And if you open it, it'll be easy to tell if everybody's looks correctly, because they'll all look the same. They should look something like this. So I want everybody to get their screen to look like this. So here we go. Here we go. There we go. There we go. There we go. Getting there. All right. So let me show you what MATLAB has done. MATLAB, I think, is a little smarter than Excel. Remember, in Excel, what you had to do is you had to tell it, okay, here's the commas are being used to separate columns and whatnot. Here you can see everything is already been sifted out. Now, a couple things. Number one, why are some of the rows blue and some of the rows, was that yellow or orange? Why the difference? Okay, the difference is because the blue rows actually contain data. They actually contain numbers. The yellow rows either contain text or they contain nothing, okay, or unusable data. All right. Now, here's what I'm going to do. Okay. You can notice sometimes it doesn't specifically work. Like, for instance, it thinks that WV-01 is actually data, because what MATLAB's thinking is, well, if WV is a variable, then WV minus 01, that's a legitimate term, even though we know that's not data. That's just a heading for a given file entry. Okay. A couple things that you can do. Number one, you can actually drag this particular region. You could say, no, MATLAB, you were kind of smart, but really all I care about is this data down here. You can drag that around. You can change that accordingly. Okay, so you can play around with that. Now let me show you a couple things. All right. So what I'm going to do is this. I'm going to drag it to just this. Okay. So if you notice, it's just that column of numbers. All right. Everybody good so far? Okay. Now, if you notice, let's look over here in the top. See where it says column vectors? Does everybody see that? Okay? Now watch what happens if I just click import selection there on the very right, if I just check it. Now go to your workspace. Look at what happened. Does everybody see that? What it did is it created a variable for every single column. Okay? So that's pretty advantageous if you're wanting to work one variable at a time. Does that make sense? Everybody okay with that? Now, let's get a little fancier with it. Okay? Why did it name the variables the way that it named it? Why did it say string 6, string 5, string 7? Why did it name them like that? It named them like that because, I think because of my font, this is a little tough to read. Let me, actually, can I? We'll just do that. If you notice, you can look at each of these columns, see how they have these sort of automatic names already assigned to them? Everybody see that? Okay. MATLAB was reading the data file and trying to figure out what would be the best name for a given variable. I don't like these names. Maybe what I want to do is name these variables associated with their gauges. Okay. Remember each of those gauges, they had a little number on them? Remember that? Okay. Let's take a look at string 6 under this, let's say this G column. I think that's string 6. Okay, there we go. Now, can everybody read the file and tell me what's the name of that gauge? What's the name of that gauge? B1, no, well, 1874. I'm looking at G, sorry, right here. But you're right. That's this file right here. Sound good? Maybe what I want to do is highlight all of this data. Maybe that's the data that I want to import. In fact, here's what I'm going to do. I'm going to highlight all of these numbers right here. Now, if you notice, I have got some yellow cells inside that range. How am I going to handle that? Well, look over here on the top sort of center portion right here. See how we've got these yellow values right here? Everybody see that? Now, what MATLAB is doing right now is it's saying any of those yellow values, it's saying replace with the variable NaN. NaN is MATLAB shorthand for not a number. Okay? So it will actually put in NaN for any one of those blank rows. So if I just go ahead and run this, and let me rename this. I'm going to go up here where it says string 6, and I'm going to rename it to B1874. If I do that, and I import the selection, hit import, look what it did over here. It created a variable called 1874. Does everybody see that? And if you double-click that and open it, notice how you've got some not a numbers, not a numbers, not a numbers, and then it starts spitting out that data. Make sense? Now that's one way of handling it. Generally what I prefer to do is this. What I prefer to do is, let me clear out all these variables because it's starting to get a little messy. Generally what I like to do is instead of replacing the unimportable cells with not a number, I like to just exclude all those rows. Any rows that don't have any data, I don't want them. Okay? So I'm just going to exclude any of the rows that are blank or have text in them so that all I'm working with is the data, and then let's import the selection. And notice it's going to name the variable B1874 because that's what we told it to do. And there you go, B1874. Sound good? I think I'm missing, did I miss one of the points? Because it should be 45. I think I missed a point on the bottom. Yeah, because it's supposed to be 45 points. Everybody good? So now that I've got that variable, now I can do some analysis. Remember, when you've got a bunch of data points, you want to do some statistical analysis. Maybe I want the minimum value of B1874, you know? Maybe I want the maximum. Remember all this? Maybe I want the average. Is this going to work? See if y'all remember. The mean. Remember, MATLAB doesn't use average, it uses mean. Goodness. Here we go, mean. Remember that? Do you all remember histograms? Remember that? Remember, if you've got a lot of data points, you would create those buckets, you know, of where the values are split up and then plot it as one big bar chart. Y'all remember that? Well, watch this. Maybe what I want to see, maybe I want to see a histogram of that variable. Now, in order to do a histogram, we have to create buckets. Y'all remember that? So remember when we had our gross vehicle weight data, we had values that were like from 30 all the way to 100 and everywhere in between. So we said, okay, any value that's less than 30, we'll put it in a bucket or a bin. Any value that's between 30 and 35, we'll put that in a bin. Every value is between 35 and 40. Y'all remember all this? Well, watch this. Here's how I'm going to create the buckets. I'm going to create the buckets to be from 0 to 2.5, and 2.5 to 5, and 5 to 7.5, and 7.5 to 10. Do I need to type all those numbers in? This is MATLAB. I can just create a vector. 0, space out at 2.5, all the way to, let's say, 40, since our maximum value is only 39.2. So there's 45 terms in that matrix. What do we have? 5 of them are between 2.5 and 5. Another 5 are between 10 and 2.5, or 12.5. Another 5 are between 15 and 17.5. Everybody seeing this? Any questions? This isn't bad, right? All right. Everybody with me so far? Okay. Let me clear out the command window and clear out these variables. You know, sometimes when I really don't know what's going on and I need some help, sometimes I'll just ask MATLAB why, and it gives me an answer. You ought to try that. Type in Y and press enter. What did yours say? The bald and not excessively smart hamster obeyed a terrified and not excessively terrified hamster. That's a good reason. Maybe I'll ask it again. MATLAB does have some silliness to it. You know, see, I'm a big fan of the 90s, so if I type in XP bombs, I can play a little bit of Minesweeper. You know, bringing it back. This is very technical material. It's going to be on the test, by the way. You like that? There's more. There's more. For instance, you can type in 15. Try and get those in order. This is somebody who has, you know, a fair amount of time on their hands. You know, and some of they're completely random. Completely random. Penny. That's a penny. If you click the little rotate button, you can actually rotate the penny. Of course, everybody needed to know how to do that, right? Not really anything to do with anything, just there's a penny. There's more, but Some of them are a little esoteric. You ought to see if you can find the Batman equation on Google or something. There's somebody derived a series of parabolas and lines and what have you that have plotted together. Looks like the Batman logo. So, you know, it's useful, you know, exercise of your time, right? All right. Enough games. Okay, let me pull up the final homework to show you all what's going on with it. I'm going to pass this out. Okay. I should have made it competitive. I should say first one to finish 15 wins an A, right? Or gets an A, right? Now, hold on. I printed one for everybody and I'm missing some. Hold on. Did you get an extra? That's it. There you go. Okay. So while you all are you know, negotiating Minesweeper in 15, let me talk a little bit about the final homework. So everybody, in all seriousness, you do want to pay attention to this. So what I have here, you know, I'm a structural engineer, and regardless of whether or not you are an electrical engineer or mechanical, by God, you are going to do some structural engineering in this class. So this is the curve that is used to compute the capacity of a steel column. For lack of a better or a more specific explanation, essentially what I'll say is that the longer a column gets, the weaker it gets, because columns under compressive loads, they tend to want to do something called buckling. If you've ever seen like a yardstick and you start pressing on it, you know how it wants to bow out? That's a phenomenon called buckling. Now, this is the curve for steel shapes, and if you plot it, it'll look something like this. So the idea is that the longer the column gets, the capacity tends to go down. Okay, so here's what needs to happen in order to plot this. If you notice, this is a piecewise function. Z is what's called the slenderness of the column. I've just kept that, tried to keep that pretty simple. If the slenderness is less than or equal to a given limit, this 4.71 square root of E over Fy, then this is your equation. Otherwise, this is your equation. So you can see, you know, here's where the if statement is coming into play. Nudge, nudge, wink, wink, right? Okay, so here's what I want the program to do. So CLC and clear on lines 1 and line 2 to clear out all your previously defined variables. And then here's what's going to happen. So the first thing that you should do is define E, which is your Young's modulus. Young's modulus is a quantity that'll tell you how much a piece of steel will deform as a function of how much load you put on it. I mean, think about a rubber band. If I take a rubber band and I pull it like that, it stretches a certain amount. That's a property related to the material, to the rubber. If that rubber band was made out of steel, it'd be a little tougher to stretch. So E is an elastic modulus for steel. Fy is the yield stress. It's how much the material can take before it permanently deforms. So define E, define Fy, and then compute this R value that you see up here. Now next, we're going to be plotting as a function of Z. So create 500 evenly spaced values from 1 to 200, and we'll assign that to Z. Create 2 empty row vectors for an elastic buckling stress and a critical buckling stress. We'll call those F sub E and F sub CR. So you should have an FE line and an F critical line, and then we get into the loops. There should be 2 loops for the homework. The first loop should compute the F sub E values using the equation that you see on the top right. if you actually investigate the f sub e values, if you actually open the variable and look at it, your first values will be really, really large, like it might be something, you know, in the hundreds of thousands. That's fine. Your values at the end should be really, really small. Then use your loop to compute f critical. Inside your loop, you need an if statement, because if z is less than or equal to r, then you're using that first equation. If not, you're using the second equation. One other thing, that fy over fe, that is not a fraction. That is an exponent. Okay, it's 0.658 raised to that fraction. Okay, so make sure that you're seeing that. Let's see, what else? You're going to plot it. You're going to assign that plot to the figure variable, you know, format it accordingly, and then enter a line of code to save it. Okay, and when it's all said and done, your plot should look something. It should look something like this. So I've even given you the final answer, so you have an idea of what the column looks like. Sound good? Now, problem number 2 is using that gross vehicle weight data. You're going to use the data import tool that we just discussed today to import some data from that gross vehicle weight data. You're going to import 2 variables, one for 2002 data, one for 2004 data. Make sure that you exclude the rows with unimportable cells. Once you've exported that data, use the save command to save those as mat files. And then once you've saved those mat files, write some code to do some basic statistics and plot a histogram. And when you plot the histogram, it should look just like the one you did in that previous in-class exercise. I mean, there won't be the line, but the bars should be exactly the same. Sound good? Well, then I'm going to shut up and let you all get to work working on this assignment. I'll be here, so I mean, if you've got any questions, I mean, please, you know, ask. But if you just take it one line at a time, one bullet at a time, I think you'll be fine. All right, that's all I got.